Hello everyone, let us continue our previous discussion on this question, and this question is asked in GATE 2025 and it is from the complex analysis part. In the previous video we have already discussed about the correctness of the statement S1. What S1 is saying? S1 is saying that here it is f is a mapping from omega to c and it is a non-constant function. Okay, and in the previous video we have shown that if f is continuous and f square is analytic, then we proved that f is analytic. If you want to go through that video, the link of that video is provided in our description box. You can check it. Okay, today we will discuss about the statement S2. Okay, we will prove that if f square is analytic and f cube is analytic, then f is analytic. But we will use the previous result. In the previous result, if f is continuous and f square is analytic, then we can prove it. Now we will use the analyticity of f square and f cube to prove that f is continuous. Then we are done, because when f is continuous and given that f square is analytic, then it implies that f is analytic by this previous statement S1. Okay, so let us prove the statement S2, and the S2 is a true statement. We will prove here. Okay, let us prove it. What is given? F is a mapping from omega to c, and given that f square is analytic and f cube is analytic, our target is to show that f is continuous, because when f is continuous and f square is analytic, these two things combinedly implies that f is analytic from the statement S1, and we have already proved that statement in the previous video. Okay, so let us prove it. We will take a arbitrary point z0. Z0 belongs to omega such that f of z0 is non-zero. Means we divided two cases. When f of z0 is equal to 0 will be discussed later. Okay, in the later case, first we will discuss this case. Okay, so take a point z0 in this omega at which f of z0 is non-zero. This implies that f square z0 is also non-zero. Why? Because f square z0 is defined in the pointwise sense. F square z0 is nothing but f of z0 times f of z0. Since f of z0 is non-zero, so f square z0 is also non-zero. But f square is a continuous function, because given that f square is an analytic function, and analytic function implies that f square is also continuous. Okay, since every analytic function is continuous, since f square is continuous, we can find a ball around the point z0, on which f square z is entirely non-zero on this ball. This is the nice property of a continuous function, and this ball is subset of omega. Since f square z0 is non-zero, therefore we can find a ball on which it is entirely non-zero. Okay, but given that f square and f cube are analytic, these two things are given. Now on this ball we can write this thing on this ball only, because f square z is non-zero, otherwise denominator will be 0. There is chances. So but on this ball, this f square z is non-zero, but f of z is equal to f cube z divided by f square z, because f square z cancel, it remaining thing is f of z. Okay, so there is no harm to write this formula, and this formula is defined on this ball, and on this ball f cube is analytic and f square is analytic. Means f cube is continuous, f square is also continuous, because every analytic function is continuous. And it is the ratio of the two continuous functions, and the denominator is non-zero. Therefore f is continuous on this ball. This is from the this is a nice property of two continuous functions. If f and g are continuous, f divided by g is also continuous when g is non-zero. But our g is here f square, which is non-zero on this ball. So therefore the ratio of two continuous function is also continuous in this case. Okay, this implies that f is continuous on this ball. Since f is continuous on this entire ball, therefore f is also continuous at z is equal to z0, which was our target. Therefore we proved the first case when f of z0 is non-zero. Now we will move to our second case when f of z0 is equal to 0. Okay, so we are taking a point on the domain omega where f of z0 is equal to 0, and we will check the continuity at z is equal to z0 of what, of f. Okay, since f of z0 is equal to 0, f square z0 and f cube z0 both are also 0 because these are defined in the pointwise sense. Okay, but f square and f cube are two analytic functions, and we know that the zeros of the analytic functions are isolated. Therefore we can find a ball around which both f square and f cube are non-zero except the point z0, because this point is an isolated point, means around that point everyone is non-zero. It is only a single point, it is a lone point, means isolated one. Okay, so we can find a ball, this one, around which f square z is non-zero for the deleted pole this, and f cube z is also non-zero. Means we are in the common sense or in the logic sense we can find two neighborhoods, but we can also take their intersection. That intersection ball is this one. Okay, so do not confuse with that one. So finally we, up to this point, we found a ball on which these f square and f cube are non-zero on the deleted ball of v1. Means we are discarding the point z0 because at the point z0 it is both are 0. Okay, and since z0 is a 0, therefore both we can also find two analytic functions g and h, so that f can be rewritten in this way, where f square z is equal to z minus z0 to the power n gz, and f cube z is equal to z minus z0 to the power m. And here the n is the multiplicity of the 0, because z0 is a 0 point, and here n is the multiplicity of the 0 of z0, and here m is the multiplicity of the point z is equal to z0 for this function f cube, and this is for the f square. Okay, so that g z0 is non-zero and h z0 is non-zero. These results are coming due to the standard results from the complex analysis. Means if z0 is 0, then we can find a analytic function gz, so that f square can be written in this way and f cube can be written in this way, where n and m are the multiplicity of the root z is equal to z0, corresponding to f square and f cube respectively. Okay, and here the notable thing is that g of z0 is non-zero and h of z0 is also non-zero, and here n and m are greater than equal to 1. Why greater than equal to 1? Because we told that already z0 is a 0, so this n can be at least 1. Okay, and these nm can be greater than equal to 1. These two things will be used in future. So now we can write that f square we can take power cube, it will gives the 6, and if we will take the f cube power 2, it will gives also the f6. Then these two things will be equal. Then we will put the value of the f square and f cube. It then finally it turns out to be this point. Okay, at this point these two functions g cube and here the function h square are analytic, and it is a polynomial function. It is also analytic and it is also analytic. Means in the left hand side it is also analytic function, on the right hand side it is also an analytic function. And we know that g of z0 is not equal to 0. Here this is also not equal to 0, it is also not equal to 0 at the point z0. It implies that this 3n is the multiplicity of the root z0, but here it is telling that 2m is the multiplicity of the root z0, because this function is non-zero at the point z0, so the highest power is 2m. So it is telling that in right hand side is saying that 2m is the multiplicity of this analytic function, and in the left hand side it is saying that it is equal to 3n, but both the analytic functions are same here, because here the equality sign is there. So 3n should be must equal with 2m. Okay, 3n is equal to 2n. From this we derive this thing. If this implies this equal with this, then this analytic function also should equal with this analytic function. These things are conclusion are coming from this step. Okay, if we simplify this step, we will reach this thing, and we already know that m and n are greater than equal to 1. Therefore this thing is greater than equal to 1. This implies that m minus n is greater than equal to here equality sign is there, not greater than equal to. M minus n is equal to n divided by 2, and n is greater than equal to 1. Therefore this quantity is greater than equal to half at least. Okay, and this thing will be used in our letter. Now we will write this one, this function. Now we will write this function, but here the we cannot write because f square z is non-zero on this ball, but it is non-zero on the deleted neighborhood. So we will take the difference of z naught. Then only we can write this formula. This formula is valid on this deleted ball. Okay, where we have excluded the point z naught. Okay, and actually these we make these type of story or calculations to define this function only. Means we have a celebrated neighborhood on which both f square and f cube are non-zero, and at the point z0 it is f square z is 0. Okay, and we need this type of neighborhood to define this limit only, because the limit of a function is defined on a deleted neighborhood of a ball. Means on this neighborhood we have this function is well defined. Okay, then only we can write this limit is equal to this, and this function is a well defined function, because z is approaching to z naught, but it is not equal with z naught. Okay, then this limit is well defined. Okay, means up to this point our construction was to define this thing. Means our main target is to show that f is continuous, and we will apply the main definition of the continuous function. If we will show that this limit is equal to f of z0, then we are done, and f of z0 is equal to what? 0, because it is the we have taken initial assumption f of z0 is equal to 0. Okay, means if we show that this limit is 0, then we are done, and to show this limit is 0, we will use this m minus n is greater than equal to half. This will be used. How it is using? How it will be used? Let us see. Here it is power m. Here we will apply the definition of the function f cube z. F cube z is equal to z minus z0 whole to the power m into hz, and f square z is equal to z minus z0 whole to the power n gz. So since z is not equal with 0, z is approaching to z0, but it is not equal with the z0. Therefore we can cancel. After cancelling, we will get z minus z0 whole to the power m minus n, and it is a positive power. The main thing is here we have proved that it is strictly greater than 0. It is greater than half, so half is a strictly greater than quantity. Therefore m minus n is a positive quantity. Therefore we can simply put z is equal to z0, and 0 to the power positive quantity 0, and h of z0 and g of z0 as non-zero quantity, non-zero well defined quantity. Here it is not equal with 0, so there is no problem to prove that it is equal to 0. But if this m minus n is 0 or negative, then this quantity will be at the, if m minus n equal to 0, then this quantity is a indeterminate form. It will be 0 to the power 0, something like, or it can be equal to 1. It will not vanish. Or if it is a negative quantity, then it will blow up. We cannot calculate, means it will be infinite, or it is undefined. Okay, therefore to prove that m minus n is positive is necessary, which was done in our previous calculation. Okay, so we proved that this limit is equal to 0, and this is nothing but f of z0. So we proved this thing. It implies that f is continuous at the point z is equal to z0. So we verified that this statement s2 is also s2 is true, because we proved that f is continuous, and the statement s1 implies that if f is continuous and f square is analytic, in the already given that our f square is analytic, and we proved that f is continuous. So by using the previous statement, it shows that f is analytic in omega. Therefore this statement S2 is also true. It is true, and in the our previous discussion we have already proved that it is true. So both the statements are true. Let us verify the options. It is saying that S2 is false, so it is false. It is saying that S1 is false, it is false. It is saying that both S1 and S2 are true, therefore it is true. And it is saying neither S1 nor S2 is true, so it is also false. So it is saying that both S1 and S2 are true, means it is wrongly placed here. It is saying that this is false and this is false, and both S1 and S2 are true, it is true. It is saying neither S1 nor S2 is true, it is also false, because both are true. Option C is true one. Okay, I hope that you all understood it very well. Thank you all.